Hi everyone, this is Tom Sandberg speaking. Very welcome to this webinar on BIM Energy and the introduction to fast dynamic calculation of existing buildings. Oh, sorry. Okay, so my name is Tom Sandberg. I work with energy calculation software here at StruSoft. And with me I have my colleague Christine Davidsson. She will answer your questions in the chat, so you have possibility to ask questions during the webinar, and they will be answered directly, more or less. We will then, at the end of the webinar, have some time to answer those questions for everyone, so we can share the info. And then if you have further questions, you are welcome to ask then, of course, also. And look at what we will look at today. We will, after a few slides about this software and our company, I will open the application and do a demo. And we will look at how we create building geometry, define surrounding conditions, the constructions of the building internal heat loads, ventilation, heating and cooling systems, and then finding energy efficiency measures and evaluate them. Just quickly about StruSoft, we are an engineering software company, and we develop our own software for the building and real estate industries. So we have many programs for different types of analysis, like structural design or analysis with FEM design. We have impact for precast factories and designers to make the drawings and also integrate with the production. And we have other specific applications and programs for calculating various kinds of design problems that encounter. And we also have then energy programs, and we have this BIM Energy, which is our newest software, and we have the VIP Energy, which has been around for some time, continuously been developed and very well spread among energy engineers who do the design of new buildings from an energy point of view. So quickly, what is the news in BIM Energy then? What we have tried to do is to do an easy to use software that can shorten the time for doing energy simulation, and thereby making it very useful when we deal with existing buildings where we need normally to be a bit faster. We don't have as much time as when we're planning a new project. And we also want to maybe just look at a small part, or making some small adjustments, installing a heat pump, or making some changes. And we can here more easily use what's in the catalog and create a model quickly. And so the aim is that we can answer complex questions about energy in existing building in an energy time efficient manner. A few words on dynamic energy simulation. This means that we do the heat balance hourly, and we use the data from climate files with solar irradiation, wind, temperature, and humidity on hourly basis. Then we add all the things we add in the software about the building, like control set points of and performance of heat pumps, air handling units, cooling machines, and etc. And then we calculate the hourly energy use of the building. And we can, of course, display it as hourly or yearly or monthly or whatever we choose. And in this calculation, then we take into consideration the thermal inertia of the building, depending on how it's built, how heavy it is. It will be absorbing and giving out energy or heat to the rooms, depending on the temperature when it goes up and down quickly outdoors. We also consider air leakage. And then a few words on, for example, the things that we can calculate with these softwares. And we can then simulate if we change air handling units or ventilation flows and the schedules for them. We can add additional insulation on roofs or walls, or change windows, compare different types of windows and see the energy saving potential, compare it with the cost, of course. And we can simulate heat pump performance. And that could be from exhaust air, heat pumps, geothermal, air to water, air to air. And we can, of course, do this for a new installation, or we can replace an old heat pump and see what the benefits would be. And also when we do energy audits, or basically looking at the energy consumption of a building, we can use these calculations to see if we don't have measurements on all entities and all consumers. We can, by using this software, we can see how much does the heat pump need and what are other things using, like ventilation and so on. So with these few slides, I would like to open the software and we will have a demo. So this, as opposed to our other software, this is on the web, so you don't need to install anything. You just log in with your personal password and user, and you will have all your work stored in this cloud. We'll make full screen there. And so this is what you see when you log in. You will have all your projects listed that you are working on. Those with 2 people on are the ones that are shared with other users. So you can share projects and buildings, and you can either share them with have full rights to the person you share so that they can change things, or you can share them that you can only view what you've done, depending on how you want to cooperate. On top here, we have the navigation bar where we see that we start here in the project, and we can choose to jump into an existing project or create a new one. Then we move on to building, and we define geometry and surrounding conditions. And later we go to the construction and define that. We go through the usage of the building, the ventilation, the heating, the cooling, and then we look at the report. We can of course jump around here as we like, but when we create a building, normally it's quite logical to follow these steps. On the right-hand side, we have the diagrams for emitted energy and supplied energy. So this is the overall heat balance. And we can see the different parameters here also. And then we have the heat supply, and below we have the electricity also. And these will update continuously as I develop the model, and especially when I do changes later to see where the potentials are, I will see this directly, how it changes. I can also choose to add a few parameters if I like to see them while I'm working. So for example, heated floor area might be interesting, the heat supply, the total heat supply, and the heat supply per square meter. But I can add any of these parameters like electricity or cooling demand or whatever I'm interested. And I can change that. So if I'm working with cooling, maybe I want to add some parameters, and but now I don't want to see them because I'm not there yet. So we start by creating a new project then. And we call this webinar October 9th. And then we choose our climate file. And we can choose here on the world map. We use the NOAA climate files. There's also the possibility to upload a climate file. So we can go to Helsinki, for example. And we use that location. And the file is uploaded. All right, so there we go. We can look at it also if we are interested in what it looks like. We go to catalog and we choose the default catalog here. That's the one with the English language, so I choose that one. And I create the project. All right, then I'm ready to go and start defining my building. Call it building 1. And here I can, if I want to, I can define the heated floor area. The program will calculate it from the geometry, but if I have some deviation here that I want to use a specific area, I can use it. And I can also choose directly from 8 different typologies where we have poorly, medium, highly, and super insulated, heavy, and light building. And this is good for starting quickly. And if I don't know more, maybe this is good enough for the time now. I can choose one and then I can later in the construction modify it as I will show later. And I can also choose to build it completely from scratch with my own materials and constructions. Then we move on to basic geometry. And here we define the story height, and it's always the inner measures that we use. We choose the number of stories or floors, and if we have a basement, we add that. And we have the width and the length or depth of the house. And so we created a rectangular building super fast. If we have another shape of the building, we go to the next step and we can edit each floor separately. If we have the whole building having a solid form, then we go to the bottom floor and we just edit it as we like. And we can choose which snap interval we want to use, how detailed we want to do this. So we go for 10 by 10 meters like this, for example. And when we're happy, we save it. And then I can copy this to the floors on top. I replace the one above. I want to keep the 4-floor building. So that way I can create basically any geometry. Then we have the windows, and we want to define how much window area do we have on each facade. So we can look at the east, for example, here, and we just change the value here. And we will see, for example, that the solar energy through windows is recalculated from 47 megawatt hours to 42.8. And we can also choose to insert an area instead if we know that number. Then we have the possibility to change. Once we choose a typology, we can change that typology, but all the walls, for example, outer walls will be changed to that construction. But here we can do, if we want to have this part different from the other parts of the house, for example, we can select the parts and change the construction. And the same goes for windows. We can also see the model that we created. Here we only have the geometry, or the 3D model, but here we can check what actual areas have we created and how much space is it. We also have thermal bridges here, and they are from the typologies calculated for all these different types of thermal bridges that we might occur. And so this is also possible to change if you go into the next step construction. Then we have positioning. And here we can find our building on the map. Now I just draw something out of the blue, so I'm lucky if I find something. This is pretty similar. I can put my house there, building. And okay, so the dimension here are not right, but we rotate the building. So this will be about 300 degrees, maybe a little bit more. And the whole idea behind this is to get the orientation of the building right, so that solar irradiation and wind will be calculated correctly. We also then have other house around here that maybe shades the house and also takes out the wind velocity. So we can go into these, for example, looking at the south here, maybe we have some high houses and we can define the angle from the house up to the house that shadows the building. So we can adjust this in all the directions. And the same goes for the wind speed. So we can choose here the percentage of the climate file wind speed that we want to use. So if we have in downtown, maybe we're down to 50% or something, or we have even higher wind speed if it's depending on the location. We can then put in the solar reflection from the ground and also the type of ground that the house is built on. So is it the rock or clay, or it will have some impact on the heat transfer. We then move on to construction when we're done with our geometry and surroundings. And we can look at this one that we choose, poorly insulated heavy building. And we can get an overview. What kind of U values does this contain? And do we want to change something, or do we want to start from scratch and create all these? In this case, I will just show you how to change one of them. Sorry. And I will not do all of this, but I will show you how to do one, and so it's possible to do all of them, of course. So then we move into constructions, and we go. We have a catalog of materials, and we can't. We can, if we don't find the material we want, we can always create a new one. And then we just edit or copy it and change the name, and then we can put in the thermal conductivity, capacity, and density. But there are many types of materials here, so generally I think you're fine with just jumping into constructions. And if you want to create our own wall now, for example, or all outer walls, we just make a copy, and that is because maybe we want to keep the original one. And the advice here is just to call it something that you will remember. So we call it outer wall 1. So we can easily distinguish it from the others which are in the catalog. And here we have the wall as it was, and I can choose to just change materials here or take away something. And I can also just take it all away and start from scratch and say that I want some wood, for example, and then I want some, this is fine with me, some insulation and woods, and then I want some something, let's take plywood. So then I created this wall, I save it. That was a bit thick, maybe the plywood, but never mind. And then I have it here. That just looks so wrong, so I have to change it. I want it like that. Okay. And as you see, I got the U value and so on for this new material here. So I can also go back and change this again if I'm not happy with that. And what I do then is that I go into my typology. I could have also created my own typology and put a name that I would easily remember. And then I go and say that I want the exterior walls to be this outer wall 1. And then I save it and we will recalculate. So we are going down from 383 to 237. So there was a big difference in insulation here. So I could have done that with all the others if I wanted. We have the same for windows, that we have a catalog that you can look at. And you can then also create your own windows or change the values here if you like. We have a catalog of heat pumps that you can use. Here you can edit and change and create and so on, but I will go into more detail here under heating, where we will use the heat pumps. The same goes for these other things like ventilation and cooling. So we go to usage, and here we have some templates that we can use. For example, if it's an office, an apartment house, or so on. I can also always create my own one, which is called building one. And I copy the values from the one I want to use. And then I can, for each of these parameters like heating set points, cooling set points, domestic hot water, human heat gain, building operational energy, internal and external, occupancy energy, internal and external. I can always just go in and change the set point, and I can also make a schedule that I want this set point to be from Monday to Friday, for example, and then all year or a specific part of the year and different hours of the day. So this is possible for all parameters. But we keep it like this and go into ventilation, and we create a new system, and we can create as many as we like, and we can choose from natural, that's only a flow, exhaust air, then we have the fan, of course, and the flow, and exhaust and supply, or exhaust and supply with a heat exchanger. Go for that one. And I can also combine here. If I have one with heat exchanger and another without, I can just add another one. Here we have the settings for the fans and the efficiency. So it's pressure and efficiency. And this then calculates the energy usage and the heat that the supplier fan actually goes into the building. And we have the same kind of schedule that we can choose if we want values per square meter or a total airflow. And we can put the schedule for the different times of day and days of the week and so on. In this case, we have 0.35 liters per second per square meter. So this is a typical residential house in Sweden, at least, probably similar in other countries. So we keep that. And then we have the settings for the air handling unit. So we can define the lowest set point for exhaust incoming air so that we heat it to at least 18 degrees. If we have cooling, we can say the same, that we want to cool it to 20 degrees. If we don't have cooling, we take it away. And then we have the heat exchanger efficiency, which we of course can modify. Let's say this is something a little bit not so good, so we can see the difference later if we exchange it. And then we have some other parameters that we can work with. We can also connect to exhaust air heat pump. So in that case, when we go into the heating dialog and choose a heat pump, we can connect it to the exhaust air, and the program will calculate the exhaust air temperature and how much heat I get from the heat pump and the electricity consumption of the heat pump. So now we basically went through all the steps where we defined the climate shell, how it's built, the usage, and the ventilation. So now we actually see the heat demand of this building. And in heating and cooling, we go into how will we supply this heat and cooling to the building. So we go to heating. If we have district heating, for example, we can limit the power that is available and look at indoor temperature or energy consumption and see what happens. We can also add circulation pumps, so we have some kind of hot water circulation. We put the watt power, what number of watts there, and then this one runs throughout the year. And then we have another part, which is the probably pressure controlled distribution pump of the heating system, which is then a percentage of the heat demand. And then we can add also internal losses from pipes. So that's typically the hot water circulation that we can add the loss and the length of the pipe to take that into consideration. And also if we have external outside the climate shell, we can put that in as well. Then we have electric heating, which is the same pretty much, and heat pumps, then we have some more things we can do. We can choose between air to air, water, sea source, exhaust air, ground source, rock, or soil or rock. Then can go for geothermal rock. And here we have all the heat pumps that are in the catalog. And these are verified with the manufacturers. So their calculation software will give you the same results, or very, very clear, very, very similar results. They, of course, are not taking the building into consideration in the same way as we can do, but for the heat pump itself, these are verified. And so we can choose any of these, and we can also choose to define ourselves a heat pump if we have the data sheet from a manufacturer, and we can then create this model ourselves. I will show you in a few seconds. But we choose this one, and we then maybe are interested in how much heat does this supply. So we add that. We want to know maybe how much heat we need. Sorry, we have this. We add the total heat supply also. So we see this. Before I had the heat supply, which was the additional heat or the heat that we needed, and I have the total heat supply where I add the heat pump. So in this case, the heat pump will supply 252 megawatt hours. We have additional heat demand for 47, and the total is 299. In this dialog, we can add a accumulator tank, and that is more important if this one is frequency control, but if we have a heat pump that only do start and stops, then we don't want it to start and stop every minute. So it needs to run for at least 10 minutes, for example, and then it will calculate how the temperature in this tank will go up and down depending on how much heat load we have. We can choose if all the house is supplied by this heat pump, or if there's some part which has something else. So we can define the percentage there. And then we have the temperature curve for the heating system, which then is important for the heat pump simulation. And then it's basically the same parameters as we saw before with district heating, with the tap water and losses and so on. We can add several heat pumps here. We can add different types, and they will be run from the priority, the first one on top, and then the second one, and the third, and so on. And we can change the settings here. And here I'm free to define my own heat pump if I have the data sheet, as I said. What we need to tell the program is what the heat source is. Is it the ground, exhaust air, or sea source? In this case, geothermal rock. And then we have the operation limits of the heat pump, and checking that it's not out of its temperature limitations. And then we have the speed control here. And we have the results from the testing, which should follow then any of these standards. So I think they are obliged by law actually to test according to these standards. So you will find it in any data sheet. And by inserting the heating output and the heating coop and temperature and hot and cold side, the program will calculate the efficiency of the compressor, and with the together with the properties of the refrigerant, we can calculate the exact operating conditions for every hour. We're actually in smaller steps, but depending on how hot temperature we need to deliver, how cold the heat source is, and how much power output, we can calculate how much electricity we need. There are some other internal pumps and so on we can add. And we can also choose how it should be connected to the building. So we can choose if we want to do heating or not, if we do tap water or not, or do both, and then how we want to prioritize in between those two. So for example, if we only have electricity, we might want to prioritize tap water. And if we have district heating, maybe we prioritize differently. That's up to you. Okay, we move forward to cooling. We can choose district cooling, which is basically a pump and relative humidity that we tolerate. So if we have some kind of drying of the air, then we take that energy needed into consideration, and we can limit the power also. With a cooling machine, we have 2 operating points, and we make interpolation in between. So maybe we have a higher COP at lower outdoor temperatures. And we can choose if we have free cooling at a certain temperature or under a certain temperature. And also we have the circulation pumps and this relative humidity. But we skip that in this case. We have a little, since in the usage, it was defined that we can only tolerate 27 degrees. So in this case, the program will make the heat balance and say to maintain 27 degrees, I will need to cool this much. But it doesn't cost anything in terms of electricity or district heating. It's more a theoretical calculation. Then we move on to the report. And here we get the basic of the project, all the inputs we put in, like surrounding conditions, what the construction looks like, windows, thermal bridges, how this usage is, which set points we use, which schedules we use, and ventilation also, the schedules, the flows, the different set points we have, the heat supply, the heat pump, and the data on that one, the temperature of the heating system. The cooling here was pretty much nothing this time. The results then is the energy balance per month, where we can see transmission, for example, and infiltration, ventilation, and what we supply in forms of heat and solar energy and so on. And we also have some key values on different things that might be interesting, like heated floor area, average U values, ventilation flow, heat loss, form factor, etc. And then we have this specification of energy supply. Here we see the heat supply, which is then the additional heat we need after the heat pump has been doing what it can. And it's divided on the heating system, ventilation, and hot tap water. We prioritized tap water now with the heat pump, so we have no need for additional heat for that. For the heat pump, then that's the total amount that it will deliver and divided on the different systems. And then we have the total heat supplies, which is the sum of these 2 above. We also get the cooling here, which I said here, it's not really relevant, but it could be in another case. And the electricity, as for example, heat pump, cooling machine. So I had a cooling machine, I forgot to take it away. Electricity for supply air and exhaust air, circulation pumps, and then these occupancy energy. And if I would have added something else, it would appear here also. And we have some diagrams of the heat balance and climate files, but you can also define your own diagrams. You do that by clicking Add Report Content. We can, for example, look at the heat supply. We take the total heat supply. We have the months, and we can also choose to go on weekly, daily, or hourly. So we see what this building would need or for each month. We can also plot it against the outdoor temperature, and then we get the kilowatt hour per hour. So we have here the average kilowatts needed per hour. So we see how much power the building needs. So this one, let's say we're this minus 18 or something, it's our temperature that we use as a design point, and we say we got approximately 90 kilowatts of power needed to heat this house. And we can then change and look at the heat supply, which is only the additional heat except for the heat pump. So we see that we will need about 45 of that. the worst month. You can also check each month or the whole year and see how this is distributed between the months. And then we have the heat pump. And there we see the simulation of this heat pump, that it's supplying all the heat up until 0 approximately. And here it's working at its maximum capacity, and it will decrease a little bit as the cold side gets colder and the hot side gets hotter. So this is a good way to see, is the heat pump adequate? Is it big enough? Should I go and try another little bigger one or smaller one? And that, of course, depends on the prices for this electricity and the installation cost of the heat pump and how much this peak heating costs. So this is basically a way to model the building as it is, and once you have this result, if you were entering correct values, this value of the heating should be very similar to the one that you have measured maybe. And so once your model, and of course you have to look at which parts am I certain of. Maybe I'm not so certain about the construction, but these parts I know very well what it is. So I can adjust this a little bit to get a model that represent the house in a good way. And then I can start with my finding potentials for energy efficiency. So what I do is that I go to the building section again, and I create an alternative because I want to keep this one as a baseline. I want to be able to go back at this and look at it. So I create a new building, which I called alternative 1, and I can choose anything, of course. I create that, and that is then basically a copy of the other building. And I can basically go in and edit everything, but typically the house is still, the building is still in the same position, and the geometry is probably the same. It could be that I want to check what happens if I add something to the building, but in this case we say everything stays the same. The construction stays the same, but maybe I want to investigate if I want to put some insulation on the roof, for example. So I see what I had. I had this roof that was poorly insulated heavy building roof. So I go into constructions, I check for this poorly insulated heavy building roof. I still want to keep this roof for the other house because I'm working in the same catalog. So I make a copy of it, and I go and edit that one, and I call it insulated roof. And then I want to add some insulation, so I add another layer. I choose this one, which is typical for adding insulation, and I choose the thickness. I'll take something pretty thick here, put it just below the outer roof, before the other parts here of the roof, and then I save it. And I will need to choose that one in my typology also, so that the program knows that it should calculate the building with this new roof. So I take that one, insulated roof, and then I save, and we will see the total here. So heat supply here is 300, and the results of this would be saving about 60 megawatt hours. I went down to 259. And I can of course do the same with any parts here. So the outer walls, maybe this is hard to insulate, the slab underground or the underground walls. But for example, windows, I could, if it's about time to change the windows, you can investigate which kind of window should I choose, comparing maybe standard window with something a bit more expensive, and see how much I will save in energy terms and compare it with the cost. So I take a really good window here, and I will see how much that will do. I had quite a lot of windows on this house, so it probably has a pretty big impact from 259 to 215, sorry. Usage, we can also change, for example, if we decide to install LED lighting, if that's not already done, or some other energy efficiency measure, then I need to lower maybe the operational building energy of the building, or if it's related to the apartments or offices. And of course, then I will have less electricity for that, but the program will also then calculate that I will need a little bit additional heat in the winter and maybe additional cooling or less cooling in the summer. But we leave it at that and go through ventilation. And here, of course, if I would have exhaust air only, I could have looked at installing a heat pump, or I could have also investigated switching with a heat exchanger if that is practically possible. In this case, I put a little lower efficiency on this one on purpose, so now we can put this up to a really high efficiency here and say that we exchange this air handling unit, how much will that result in? And then we were at 215, and then we're down to 167. So we came from 300 now to 167, and maybe these were quite extreme cases, and then we can go and change the heat pumps, but maybe it's a good idea, since we save this much energy, it may not be the right thing to actually change this or add another one, because as we increase the energy demand and power demand, we probably are pretty fine with this one. But if in the case this one was an old heat pump or something, we could have exchanged it. But I go straight to the report then. And of course, now we can see the same things for this new building. And we can also, for example, we created a baseline. Maybe we want to have this report a little bit shorter in order to just highlight the differences that we made and the results. So I can unclick these boxes and take away everything that is not really interesting. So let's say I didn't change the usage, then I just unclick it and the construction didn't change, but it did in this case. But the values of the glazing didn't change, the surrounding didn't change. So we have a more compact report here, just stating what we've done and how much we saved. You can of course print this to PDF or paper, and all the changes we do all the time is always saved. So we don't really need to press save. It will always be when you log in again at the same state as you left it in. But now let's analyze what happened with the heat supply. We can look at the total heat supply. We see the months, and we can see the as a function of the outdoor temperature. And I think we were about 90 when we started this, if I'm not remembering wrong. So we got down to 50 now, almost half of the energy demand. Of course, the ventilation system plays a big part, but also the roof and the windows. So we have 50 in total for the house, but the heat we can look at the heat pump first. What the heat pumps supplies now, we see directly that this one actually copes all the way down to, let's say, -13, and then it drops off a little bit. So now it's probably the right size. And then we have the additional heat supply, which has then dropped to only 5 kilowatts. I think this one was on 30, but I'm not sure, something like that. So we can compare this now with what this will cost us, this peak. And we can also, of course, check the electricity. We can check the electricity for the heat pump only. So we can see what will this cost us to run this. And we can then see how much do we saved in energy cost compared to if we wouldn't have done these things and evaluate if it's profitable or not. This was pretty much what I wanted to show you. So I think it would be great if Christine could have some of the questions and we can answer maybe together.
Yes, hello. We got one question about adding several ventilation units. Is that possible?
Yep. So this is, you just create another system and you define the name, of course. And then you you can select any of these kinds of ventilation. And then you just create it and you put in all the settings and so on. So it's possible to have several and of different types.
And just to mention, it's the same for the heat pumps.
Yes, exactly.
That you add several ones.
Yeah.
Yes, one other question about the languages.
Mm-hmm.
What languages is possible?
Right now we have support English and Swedish. So for the time being, it's those two. And while I'm up here where we switch between languages, I will also point out that we have the support, so you can call us or write an email and we will answer your questions, of course. And we can connect like this and show you or discuss if there's something that you find difficulties with. And we have a manual and tutorials. So in this tutorial, we have videos of each picture here that we explain in a short video how to use it. And if there are more questions, you can go into the manual where it's more described in detail how certain parameters should be defined and what they do and so on.
Yes, and can you tell us a little bit about the users of BIM Energy and what kind of projects they use it for?
Yes, so we have, let's see, can I close this now? That was, there we go. This is some examples of our customers. So it's basically real estate companies that own their own buildings and have a high ambition to work with energy efficiency. So this, for example, is a municipality in Sweden, and they have a lot of schools and kindergartens and elderly homes and so on, and also other types of buildings. So they are using a method to model their buildings, of course, gather all the data, create the model, and then find the best opportunities to save and then implement it and evaluate the results afterwards also. And this is the same for, this is another municipal building or housing company. And this one is Familjebostäder in Göteborg. It's the Gothenburg municipality's company for housing. And then we have also consultants, of course, that work with, for example, Sweco, Kiva, Inspecta, and all these others that work with what we have in Sweden, energy audits that are legally, you have to do it every 10 years. And so then you basically rate the house, so to say, how much energy does it consume, and you also are, you should give advice on which energy efficiency measures are the best one for that property, so that you should always make something better until the next 10 years. And then we have installation companies like Caverion that use it for when they do offers or projects with customers and calculate how much energy can we save by doing this and that. Also energy company like Kraftringen, which is the municipal district heating company in Lund, and they help their customer to save energy. So it's different kind of companies, but they're all into energy efficiency in buildings.
Yes, and now after the webinar, how do you, if you want to try BIM Energy, how do you do then?
Yes, we will love to give you a trial license for 2 weeks, so you can try this out yourself. And of course, we will help you out if you need to. And we will send an email to everyone, so you will have the details on how to contact us or the instruction how to start this. So you will get that today after this. And yeah, so basically you're free to try it if you want.
Yes, and that was basically the questions that we got in during this webinar.
Okay. So then I guess we just wish everyone a nice weekend and hope to hear from you soon. So that's it for us. Bye-bye.